With any acid and base reaction, it's important to choose the right solvent. But before we can choose a solvent, we need to make sure that the actual reaction will go through. So we look over here and we have a terminal alkyne with a pKa value on this hydrogen of 25. And this reacts with sodium amide to make the sodium salt of the alkyne and ammonia. And we look over here and ammonia has a pKa value of 38. So we're going from 25 to 38, which with a lower pKa value to a higher pKa value. So this reaction will go to completion. And now we can consider which solvent we want to use. When choosing a solvent, it's important to remember two things. The solvent can't react with the base, and it also has to keep both of the reactants in solution. So here we have a list of common solvents, and we're going to look through and make sure that it makes both of those requirements. So first we have water, which has a pKa value of 15.7, and when reacted with sodium hydroxide, we get, or sodium amide, sorry, we get NH3 and NaOH, which has a pKa value of 38. So it's going from lower to higher, which means the reaction is going to go through, and it means it's reacting with our base. So this is not going to be a good solvent. Next, we have sodium amide plus ammonia, which has a pKa value of 38. And when it reacts, we're going to get ammonia and sodium amide. So we see that even though we're destroying this base and making ammonia, we're making another sodium amide. So really, we're going from 38 to 38, and we're ending with what we started with. So this is going to be a good solvent to use. Next, we'll consider ether, in this case diethyl ether. And the only hydrogens on there are on the sp3 hybridized carbons, which have a pKa value of 50. So when reacted with sodium amide, we get sodium amide and diethyl ether because the pKa values are 50. It's not going to react with the sodium amide. So this is going to be a good solvent to use. And our last solvent we're going to consider is hexane. And we have sodium amide, and when it reacts, we, again, because of the pKa values of 50, we get what we started with. And this may seem like a good reaction, except that this is polar and hexane is nonpolar. So it's not going to keep the reactants in solution, so therefore it would not be a good solvent. So if we go to review, sodium amide will not work with water because it will react in an acid and base reaction. It will work with ammonia because we get the same things on the product side. It will work with ether because it doesn't react and it's in solution. And it won't work with hexane because it won't stay in solution.